Hi, welcome back everyone. Today our focus will be calculations of excretion rate and glomerular filtration pressure. First, let's start with excretion rate. What is excretion? It is the elimination of all waste products along with any excess solutes or water. The formula we use for this is E equals S plus F minus R. S is for secretion, F is for filtration, R is for reabsorption. Now let's try some practice problems. These are the values, solve them, and come back when you're ready. Number 1. First, let's get our formula, then let's plug things in. Now, let's do the math. 8 plus 6 equals 14. 14 minus 7 is 7, so the excretion rate is 7. Number 2. First, let's grab our formula, then let's plug it in. Now, let's isolate our variable by moving 1 and 9 over to the other side. This would make the filtration rate 8. Number 3. As always, let's grab our formula, then let's plug it in. Now, let's isolate our variable. First, let's move the 8 over. Now, let's move the 14 over. This makes our secretion rate 1 mm per minute. Number 4. Let's grab our formula and plug in our variables. We can combine 15 and 14, which equal 29. Now, we can move it over to the other side. Now, our problem is negative 9 equals negative R. So, let's get rid of the negative by dividing. And our reabsorption rate is 9. Now, let's move on to GFP. GFP means glomerular filtration pressure. We have 4 terms: GFP, PGC, pi symbol GC, PBC. PGC stands for the hydrostatic pressure of the glomerulus. Pi GC stands for the colloid osmotic pressure. PBC stands for the hydrostatic pressure of the Bowman's capsule. Now, let's try these practice problems. Take a few seconds and come back when you're ready. Number 1, let's use our formula and plug in our variables. Now, there's 2 ways to solve this problem: the mathematically correct way and the way without distributing the negative. Let's work on the mathematically correct way. First, we're going to start off with distributing the negative in the parentheses because PEMDAS, P-E-M-D-A-S. Please excuse my dear Aunt Sally. This stands for parentheses, exponent, multiplication, division, addition, and subtraction. Now that we've distributed the negative, our problem will be 30 equals 52 minus pi GC minus 14. Now, let's combine 52 and negative 14, and we'll get 38. Now we move 38 to the other side, and we get negative 8 equals negative pi GC. Now, let's divide by a negative, and now our colloid osmotic forces is equal to 8. Number 2. First, let's plug in our variables. Then, we can choose to distribute, or we can just add what's inside the parentheses since they're both numbers. Here, we get 18. So this means GFP equals 40 minus 18. So GFP equals 22. Number 3. First, let's plug in our variables. Now, let's start with the parentheses. We have 2 numbers, so let's add them. So now we have 22 equals PGC minus 20. Now we can add 20 to both sides, and this makes hydrostatic pressure of the glomerulus capillaries 42. Number 4. I'm going to solve this in the manner where I don't have to distribute the negative. But first, we plug in. Now, I'm going to move 42 over to the other side to combine like terms. Now I have negative 23 equals negative 14 plus PBC. Now, to get rid of the negative, I'm going to divide by negative 1 on both sides. This will result on a positive side on both. And now I'm just going to move 14 over to the other side. This makes the hydrostatic pressure of the Bowman's capsule 9. Now let's try it the mathematically correct way, just to compare our answers. So first, we plug in our answer. Then we distribute our negative. This will give us 19 equals 42 minus 14 minus PBC. Now we combine like terms and we have 19 equals 28 minus PBC. Now we can subtract 28 from both sides to isolate the variable. And now we have negative 9 equals negative PBC. To get rid of the negative, we divide by negative 1 on both sides. And now the hydrostatic pressure of the Bowman's capsule is 9. The reason I showed you both ways is because I personally don't distribute the negative because I don't like seeing a variable with a negative, so I just go around it. But you should use the way that feels most comfortable to you. If you like the mathematically correct way, it is safe and will guarantee you the right answer. Other than that, have a great day and good luck on your studies.